For this learning target, I can solve systems of equations using substitution. Substitution means to replace with an expression of equal value. We're given two equations, y equals negative 4x plus 8 and y equals x plus 7. In each of these equations, the value given in terms of x says that it is equal to y. So what we're going to do is we are going to replace y in one of our equations with its equal value from the other equation. So for example, we know in this top equation y equals negative 4 plus 8. So negative 4 plus 8 is the same as saying y. So we will replace the y in the second equation with the negative 4x plus 8, writing a new third equation. So my new equation, I do not use y, no y. Instead of using y, I use what I have the expression circled. So I'm replacing y, I'm substituting for y. I'm replacing y with what is in my circle, negative 4x plus 8. And my rest of my new equation is actually continuing with the rest of this equation. Equals x plus 7. So I have one piece of the equation from the first equation and one side of the equation from the second equation. And I've set the two expressions equal to each other so that I can now solve for x. Notice that when I replaced the y with negative 4x plus 8, I was able to write an equation that only has an x in it. I no longer have a y in my equation. So to solve for x, I am going to start by trying to get all of my x's on one side of the equation by subtracting an x from both sides of the equation. Negative 4x minus x is negative 5x. I keep the plus 8. I keep the equal sign. X minus x is 0, and I keep the positive 7. Now I have a regular two-step equation, like I've solved many times in pre-algebra and algebra 1, and I need to get the x's alone, so I'll subtract 8 from both sides, keeping the negative 5x. 8 minus 8 is 0. Keeping the equal sign, 7 minus 8 is negative 1. And I'm going to undo the multiplication of negative 5x using division, dividing both sides of those equations by negative 5. And x is therefore equal to a positive 1 over 5. Keeping my solution as a fraction. Now, I know from graphing that I actually need a coordinate. I need an x value and a y value to have a solution. My x value, I now know, is 1/5. So now I need to figure out what is my y value. So I'm going to substitute the x value of 1 over 5 into my equation y equals x plus 7. So y is equal to x, but x is 1/5 plus 7. So y is equal to 7 and 1/5. In fraction form is an improper fraction, would be equal to 36 over 5. And I have my solution to this system of equations. for my second system of equations, I notice that I do not have an equation that says y equals. I have two equations, both of which are in standard form. In order to use substitution, I do need one equation, or both, to say either y equals or x equals. So I'm going to rewrite the second equation to say y equals. And I choose the second equation to say y equals because it requires less steps to get into y equals form. So the first thing I'm going to do is get this equation by adding 6x to both sides into y equals form. Negative 6x plus 6x cancels. I keep my y, I bring down my equals, and I now have negative 7 plus 6x. So I know that y is exactly the same as negative 7 plus 6x. So I am going to replace y in my top equation with the negative 7 plus 6x. It's going to go right in here. I keep the 3, but I'm going to replace the y. And when I replace the y, because I do have a coefficient of 3, I will need to use parentheses around my negative 7 plus 6x. So I'm going to write a new equation. And the new equation will not use the variable y. It will only use the variable x. It starts with 3. It then uses parentheses for negative 7 plus 6x, replacing y. I then continue with plus 2x equals 4. And I use all of the algebra skills I have learned to solve this equation for x. First with distributing, 3 times negative 7, negative 21. 3 times 6x, positive 18x. I keep my positive 2x equals 4. My next step in effort to get x's by themselves would be to add 21 to both sides of the equation. So we are going to add 21 to both sides of the equation. Negative 21, positive 21 cancel. I keep my 18x plus my 2x, and that now equals 25. 18x plus 2x is actually the same as 20x. So I have 20x is equal to 25. I'm doing the multiplication by dividing by 20. I have x is now equal, 5 over 20 is the same, 25 over 20 is the same as 5 over 4. If you prefer, 1.25. So my x value for my coordinate is 1.25. To find my y value for my coordinate, I will substitute 1.25 into my equation for x. So I look back to this equation, y equals negative 7 plus 6x, and I have y equals negative 7 plus 6 times 1.25. And I'm running into my other equation, separating that. So y equals, order of operations tells me to multiply prior to adding. So 6 times 1.25 would be, let's see here, 7.5. So negative 7 plus 7.5, y would equal 0.5 or 1/2. My answer is 1.25, comma, 0.5, and that would be my coordinates.